Hello, hello, hello. This video is on reviewing radicals. Some might think, what is a radical? This right there is a radical. A root radical is the same thing. Taking the square root, or whenever you have this symbol, it's called a radical because they're radical. So when we have radicals and if we have perfect square like so, then that should be an easy one, and that would just be equal to 4. Right now, you should pause the video and come up with all the perfect squares that we have. If there are any of these perfect squares that you don't know off the top of your head, you should be writing these down, because this is always going to be a great reference for you to come back to. Now, what happens if you have a number and you don't know what this square root would be? You have to simplify. When you're simplifying, you want to try to think of two numbers, one being a perfect square that would multiply to get 28. So when I'm thinking of this, I could say 4 times 7. That's the same thing as 28. Now I could split this up to the square root of 4 times the square root of 7. So then this final answer would be 2 square root 7 right here. So again, just to reiterate, you should find factors that are perfect squares. So in this case, 4 is a perfect square. And then rewrite them separately, and doing the square root of 4 would be 2. So again, that would be my final answer. I can't do anything with the 7. Another way that you could do these is you have to find all the factors of 96. If you can't look at 96 and know exactly what a perfect square factor would be, I would do a factor tree. So if square or 96 numbers that multiply to get 96 could be 3 and 32, and then this could be 8 and 4. This could be 4 and 2. I'm going to stop right there, because whenever you have a pair, like so, I have a pair of 4s, that means that that's a perfect square right there. So if I rewrite this, I could do 4 times 4 is 16 times 3 times 2. And then I could have the square root of 16 times the square root of 6. And this would be 4 square root of 6, and this right here would be my final answer. So you could do it either way. If you're not good at finding out what the factors with a perfect square are, I would do a factor tree to look for pairs, because all this means is you're looking for two numbers that would multiply to get out of the square root. You should pause the video and attempt this problem by yourself. You should get 5 square root 5. Again, pause the video. Attempt this one all by yourself. You can do it. Answer here would be 2 square root 6. One of the biggest mistakes people do here is think, okay, 4 is my perfect square, so I'm going to take 4, and they would have this as an answer. No go, don't do that, because you're taking the square root of 4. That's why you're looking for perfect squares, because they can come out of the root easily. Try it again. Answer should be 2 square root 3. Keep it up, keep it up. Try it again by yourself, please. So this answer here would be 6 square root 2. You could have come up with a different work, but as long as you get 6 square root 2, that's fine. I'll walk you through my work. I did a factor tree. First, I had 9 and 8. I knew that 9 was a perfect square, so I stopped with 9. And then, when I broke up 8, I had 4 and 2. Now, 4 is also perfect square, so I rewrote them both separately, because the square root of 9 is 3 and the square root of 4 is 2. So once I have them on the outside, they're all being multiplied together. So I did 3 times 2, and that's how I get the 6. Or, if you knew that also the square root of 36 and the square root of 2, that's the same thing, and that's how you could get 6 square root 2 also. But sometimes it's hard to know 36 times what would equal 30 or 72. Try it again. You should get square root 2 or 2 square root 6. Again, I broke it down to 12 and 2. I didn't have a pair yet, and then I had a 4 here. So once I had a 4, I rewrote it for the square root of 4, square root 3, square root 2. These two can't simplify, so I brought them back into just 1 square root. So that would be your final answer. Now here's another problem, but just a little bit different. Now if you have a division with a square root, I can rewrite this. So it says the square root of 18 over 2. These two things are the exact same, it's just written differently. The reason why I'm rewriting this is because I can simplify this fraction, because 18 divided by 2 is going to be the same thing as the square root of 9, and the square root of 9 would be equal to 3. So this answer is also equal to 3. So again, with this problem, I'm going to rewrite so it says the square root of 48 divided by 3. And if I do 48 divided by 3, I would get the square root of 16, which is equal to 4. So this answer is the same thing as 4. Just how you could take two square roots and write one big square root over a fraction, you can work backwards. So if this whole square root is over the full fraction, I can rewrite it so it has the square root on top over the square root of the bottom. The reason I wanted to do that is because both of those are perfect squares. So the perfect square of 81 is 9, perfect square of 4 is 2. So my answer here would be 9/2. And that concludes reviewing of radicals. I hope you had a radical time reviewing radicals. Have a great, grand, wonderful day.